Okay, now, straight line has form y equals mx plus b, and I believe we're familiar with this. Okay. If I have any 2 points in the plane, I can draw a straight line through them. And as long as one point isn't directly above the other, I'm going to get a straight line from this point. Okay, if one is directly above the other, well, it's just x equals whatever x equals. We'll look at that later. So let's just take these 2 lines, and I'm going to suggest that everybody draw a line through these 2 points and estimate the y-intercept, which is b. Okay, estimate what you get when y equals 0. I'm sorry, when x equals 0, that's on the y-axis. So if x equals 0, you know y is going to equal b. So if you can figure out what the coordinate of the point where the line intersects here might be, then you can find the b. And of course, m is the slope, and it's easy to find the slope between these 2 points. So now we're just going to do an estimate, and then we're going to figure out how to actually calculate it. So go ahead and do your estimate. Draw the line, estimate the y-intercept. And then while you're at it, go ahead and find the slope between those 2 points. Okay, so if I sketch a line between these 2 points, I think it's going to look something like this. And it's going to intersect the y-axis here. Now we know this is a point 1, 3. So we know this is a line where y equals 3. If y equals 3 here, what does it equal here? Well, it looks like it's just a little lower, it'd be like 1.5. Okay. If I try to mark equal intervals, okay. Well, why mark it? It looks like that might be y equals 2. I think 2 is a little bit too high. I think it's a little less than 2. Let's just estimate. This is a good estimate. We're going to estimate that this point is 0, 2. Then the equation would be, well, we have to find the slope. How do we find the slope? We're going to draw a horizontal leg and a vertical leg and a triangle whose hypotenuse is the 2 points. So the triangle has vertices here and here. It has a run, it has a rise, and it's easy to calculate the rise and the run. The run is 5 minus 1 equals 4. I mean, you can just count. Here's x equals 1. Here's x equals 5. So 1, 2, 3, 4, 5. Okay, it's 4 units. Now, if you got to calculate it, you subtract the 1 that you start at from the 1 that you end up at. That gives you a plus 4. And that's exactly what the run would be if we go from the leftmost point to the rightmost. And then here we got the rise. And the calculation would be 5 minus 3 equals 2. And it's obvious we go from y equals 3 to y equals 5, we go up 2 units. So we go from x equals 1 to x equals 5, we go over 4, and then we follow the path up to y equals 5, we go from y equals 3 to y equals 5, we get the rise equals 2. So the slope is 1/2. Okay, well, now that would mean that the equation of the line, according to our estimates, this might not be accurate, because remember, I really don't think that's two there, okay? Really don't think we've intercepted two, so I could be wrong. So. Using the estimated y-intercept, the equation is y equals what? Mx plus b. M's a slope, so it'd be 1/2 x plus b, which is your y-intercept, which is 2. Okay, how does that work? Well, the 0.55 is supposed to be on the line. Okay, let's test it. If x equals 5, do we get y equals 5? And if x equals 1, do we get y equals 3? We'll go ahead and plug the x coordinate of this point in and see if you get the y coordinate, and plug the x coordinate here in and see if you get this y coordinate. Okay. Well, we're going to see that it doesn't work. If x equals 5, you don't quite get 5, because half of 5 is 2.5. You add 2.5 to 2, you get 4.5. That's close to 5, but it's not 5. Now let's work it out. I'm not going to do all the arithmetic, but that's going to be 5 halves. 2 is 4 halves. You have that, you get 9 halves. Or you can take 2.5 and 2 and directly get 4.5. And that's not 5. So our equation isn't right. It's close, but it's not right. And if you do this with 1, 3, you get 2.5 here, not 3. Okay, so and that kind of tells you, since you're half a unit low in each of these, that if we've done this right, the y coordinate would be half a unit higher. Now, you don't have to do that because that's not really where we're going. Okay, so you should have gotten if x equals 1, y is 2.5, not 3. What we want to do, okay, what we want to do is say that, okay, we know y equals 1/2 x plus b, because m is a slope, and we think we did the slope right. Okay, so if y is 1/2 x plus b, we also know that y equals 5 when x equals 5. Well, that means that we could substitute 5 for y and 5 for x, and that would give us an equation we can solve for b. We substitute these values into y equals 1/2 x plus b. I'll go ahead and replace y with 5, and replace x with 5, and see if you can solve what you get for b. And we're going to do it in a minute. So if you see if you can get that substitution, then see if you can solve the problem. If you just get the substitution, that's okay. We can solve the equation, and that's not difficult. Okay, so the substitution, we're going to substitute 5 for y, that means y is going to become 5. We're going to substitute 5 for x, so x is going to become 5. And we fill in the rest of the equation. We get 5 equals 1/2 times 5 plus b. Now, hopefully you got that. If you didn't, make sure you understand where it comes from and how to do it. And then, can you solve this equation for b? Okay. Well, what we're going to do with this, I would multiply both sides of the equation by 2. And I get 2 times 5 equals 2 times 1/2 times 5 plus b. And that comes out to 10. 2 times 1/2 is 1, so 2 times 1/2 times 5 is 5. That's 2 times b is 2b. And that eliminates my fractions and makes it a little easier to work, because it's easier to work the equation when you have integers. Okay, now you could have done it, half of 5 is 2.5. Subtract 2.5 from both sides, you get 2.5, so b is 2.5. As I kind of indicated before, from a different type of reason. You don't have to understand that reason, but we want to understand this. So we solve for 2b and put the 2b over here and subtract 5 from both sides. We get 2b equals 5. So b is 5/2 of 2.5. Now we know that the equation is y equals 1/2 x plus 5/2, or 1/2 x plus 2.5, but we usually want to do our calculations with rational expressions, integer over integer, instead of mixed numbers like 2.5. Okay, let's verify. This worked for the point 1, 3. If you put in x equals 1 and y equals 3, that ought to give you an identity. So we want to substitute x equals 1 and y equals 3 up here and see if it works. So go ahead and do that. Okay, well, does this work for the point 1, 3? But remember, now we started with these 2 points. We estimated a y-intercept. We found that we're close. But what the equation y equals 1/2 x plus 2 is close. But if we substitute x equals 5, we don't get y equals 5. Okay. Now here, if we substitute x equals 1 and y equals 3, we get y is 3. There's our 3. And x is 1. We have 1/2 times 1 plus 5/2. We're going to have to go ahead and add the fractions. We could multiply everything by 2. And I've already got 1/2 times 1. I don't need to repeat that. Okay, 1/2 times 1 is 1/2. And to that we add 5/2. And we have 3 equals 1/2 and 5/2 is 6/2. And that equals 3. So we verify that this is the equation of a straight line through these 2 points. Now this gives us a method. If we've got 2 points, we can find the slope. And then we don't have to do estimates. I wanted to do estimates because sometimes you need to use estimates, and sometimes you learn something from doing the estimate. You know, like the estimate is close, but not quite right in this case. But we don't do that in every case. We want to quickly get the equation of the line, we find the slope. And then we write the equation out with the slope. Here's what we did. We just skip. Well, we start here, we find the slope, and then we say, okay, m is 1/2. So we write out the equation of m equals 1/2. Then we just take either one of our points. It'll work no matter which point you use, and it'll probably be a good exercise for you that use 1 and 3 instead of 5 and 5 over the x and y coordinates, and see that you get the same thing. In any case, we pick either point. In this case, we pick point 5, 5, where y is 5 and x is 5. Substitute those values into the equation that contains our slope that we already found. We get an equation we can solve for b. And once we solve for b, then we can replace b with that value. And here we have the equation of the line. And then we verify that the equation works for both points, and especially for the point that we didn't use this substitution step. Okay, so that's a simple procedure, and it's a good start for some more complicated procedures we're going to see later, and it gets the job done for the linear function. Yeah. Okay. I don't know why I just did that. It's like I was turning it off. Okay. So let's say we have the 0.37 and we already know the slope. How are we going to find the equation of the line? So we know the equation is y equals mx plus b. So what's the first thing we know? Think about that. I'm not going to stop the video, but think about it for a minute. What can I substitute for what in this equation? Okay, well, there's several choices. First one might be the slope. Okay, so we might say that y equals -2/3 x plus b. That's certainly going to be valid. We also know that y equals 7 if x equals 3. So we can write 7 equals -2/3 of 3 plus b. Well, -2/3 times 3/1, the 3 will divide out. We get 7 equals -2 plus b. So b equals 7 plus 2, which is 9. And now our equation is y equals -2/3 x plus 9. Now, one thing we could do, let's see, if this is 3, and 3 more is here, and 3 more is here, it looks like the x-intercept ought to be about 9. Okay. Well, the x-intercept occurs when y equals 0. Okay. If y equals 0, is x equal 9? No, my estimate wasn't very good. Well, you can find the intercept. If you let y equals 0, you have an equation you can solve, and you're going to get x is about 13.5, 12.5, 13.5. Okay. If you let x equal 0, you're going to get y equals 9, of course, that's your y-intercept. So you can calculate the equation of the line if you know a point and the slope. or you can calculate the equation of line. If you know 2 points. That's the point slope form and the 2-point form of the equation of a straight line. Okay, now let's summary of what we did, working ahead a little bit. Working on factoring, so we have to factor x squared plus 5x plus 6. And we found that some people remember the tricks to do it. You got to find a number that adds up to this and multiplies out to this. But we want to talk about exactly why that works. So what I'm saying then is, okay, if I actually factor this, I'm going to get x plus 2 times x plus 3. Now, why does that work? By the distributive law, x plus 2 times x plus 3 is x times x plus 3 here, plus 2 times x plus 3, which we have here. And then if we use a distributive law again, x times quantity x plus 3 is x times x, which gives us x squared, plus x times 3, which is 3x. And then here we get 2 times x and 2 times 3. And then if we add these terms up, we've got 3x and the 2x add up to the 5x. So we see that the 2 and the 3 we got here add up to 5. And the 2 and the 3 here multiply out to 6, because we are going to do x times 3 and x times 2. Going to give us 5 times x. We're going to do 3 times 3. Sorry, 2 times 3, which will give us the 6. Okay, well, if we're trying to factor something and we aren't sure what to do, we can always list possibilities. Now, I'm pretty sure that we can all factor this after understanding this, but let's just see how we list possibilities rather than using a trick to find what 2 factors of -6 can add up to 1. Okay, because that's essentially what we ultimately do, but we want to understand why it works. So we could write that as, well, okay, that equals x plus something and x plus something, or x plus or minus something, x plus or minus something. We don't know what numbers to put in here. The numbers that we're going to use are factors of 6, because we know just like the 2 times 3 multiplied here to give us the 6, this number times this number are going to multiply to give us -6. So the 2 numbers have to multiply to -6. Well, we write x plus 6 times x minus 1. There are 2 numbers that multiply out to -6. Or x minus 6 times x plus 1, that's not possible. X plus 3 times x minus 2, or x minus 3 times x plus 2. Okay. Well, if we look at these, we know that this is going to give us a 6x. And this is going to give us a -x. And that's going to give us 5x. That's way too big. So a -6 is going to give us a -6x. It's only going to give us a 1x. And we want to maybe write out the distributive law to make sure we understand why that is. But that's going to give us something that's too big. We're not going to get x out of either this or this. And we kind of see that almost in advance. So we cross them out. And when you get used to this, you can just kind of, well, I'm not going to even write that up because it's obviously not going to work. Some things obviously won't work. Some things look like they might work. Okay. Well, here are 2 other possibilities. -6 could be 3 times -2 or -3 times 2. So 2 more possibilities. And of course, one of these works out and you use a distributive law and you find that it's this one. You're going to get an x squared. You're going to get a -3x and plus 2x, which is a -x, and a -6. Now, I recommend you write out the distributive law and see how everything goes together and see what the full pattern is, because factoring involves a lot of tricks when it comes down to the distributive law. So you want to understand the tricks, but you want to understand why the tricks work. Now, if we have this, okay, we can list all kinds of possibilities for what to put here. Okay, you're going to have a 4x and an x to get a 4x squared. Then we're going to have 2 numbers here that multiply out to 6. And I wrote down a couple of possibilities, don't make sense at all, they don't even multiply out to 6. So let's correct that. Let's pretend I never wrote these two. Because in either case, do we get a 6? Sorry, obliterate that. Okay, so we get a -6 and a -1, you get a +6. Okay, and it looks like I'm thinking in terms of, well, let me do it right. Worked out in class, got the point. But, well, I think it's great. So we could do a 4x and an x. What are our possibilities? We could do +6 and +1. -6 and -1. Or we could do 4x + 3, 4x + 2, 4x - 3, and 4x - 2. In every case, these two numbers multiply out to 6. If you use a distributive law, just like we did over here, you see if these two numbers will multiply out to whatever you get at the end. Okay. Now, 6x and 1x, well, both of these give us positive multiples of x. We're not going to get a negative multiple of x out of this. And we're not going to get a negative multiple of x out of this because everything's plus. Now we want to check both of these out. So we have a -6x and a -4x. That's going to give us something that's close. That's going to give us 4x squared -10x + 6. So we might even feel like we're getting close, but unfortunately we are. Okay. This is not going to work. Okay. Here, if we use a distributive law, we're going to get a -12x and a -8x. And if I did that right, we get 4x squared -20x + 6. That's what we. Well, it doesn't have to be 4x. Well, I'm not doing great here. Starting things down without thinking, if I tell you not to. Okay. I wrote 4x in both of these. Okay. We can do 4x + 3 and x + 2. We could do 4x -3 and x - 2. We could do 4x - 2 and x - 3. Or we could do 4x + 2 and x + 3. We have all pluses, just like up here. We can dismiss it. Okay. So if we multiply this out, we're going to get a -3x and a -8x. That's going to give us 4x squared -11x + 6. And this is going to give us -2x and -12x. So that's going to give us 4x squared -14x + 6. Other possibilities I haven't written down. Okay. I did 4x - 6 and x - 1, or I could do 4x - 1 and x - 6. I didn't write that down because if I have a -6 over here, I'm going to get a -24x. There's no way to get to -9x. I'm going to do that. As it turns out, you can't factor this on integers. Okay. Because none of the possibilities work out. Now you have to be careful to list all possibilities. You can make this. Okay. Now I have to start. We have to be able to finish this. We looked at this one. And then we did a couple of special products. So there it is, as a reminder. But, remember, we're working way ahead. We're working here with somebody that's a chapter. And, unfortunately, I don't have time to go over this.